In this video, we will discuss the problem spiral traversal of a matrix. The problem says that we'll be given a matrix which will be rectangular in dimensions and it can be a square as well. So you have to print the elements of the matrix in the spiral format. For example, if we were given this particular matrix here, so you can see that we have to basically spirally traverse the matrix one by one. So firstly, you can see element 1. So we have to move in the rightward direction. Then once the rightward direction is over, move down, then move towards the left side, then move up, then move right, then move down, then left. Like this you have to keep on iterating. So this is what you have to do, and you have to print the elements in that particular order here. Now how can we solve this problem? If you see, like initially wherever we are standing at, the first trigger movement will be towards the right side. You can see here that firstly we'll try to move in the right direction. If the right direction gets over, we have to move in the downward direction. If the downward direction is over, we have to move in the left direction. Then we have to move up, then right, then down, then left, and then up. So we have to move like this, and we have to print all the elements as we keep on encountering them. So how can we do this? So in order to move in a particular direction, we can use the concept of dx dy array here. So let's say we can maintain a dx array. Now that name can be different, but let's assume it as dx array. We'll see what we have written in the code. In the code we have dr array. So let's write it as dr here. Now let's say this is dr, and let's say this is dc. Now suppose that, like, what is the very first direction in which I'll be moving? So the very first direction in which I'll be moving is the rightward direction. Now understand one thing, if you are at a particular cell x comma y and you're moving in the right direction, if you're moving right side, so what happens? X remains the same, the row remains the same, the column increases by 1. So what you need to do is you need to say that x will remain 0 only, but the column will increase by 1. So let's update this as 1. Now how will this be helpful? Because this is the 0th index, and the 0th index of the dr and the dc array, they indicate the small change that you need to do in your x and y coordinate in order to move in the rightward direction. Now if after this, what is the next direction that we are looking for? The next direction that we are looking for is basically the downward direction, because after right is done, you have to move downwards. So next update that you have to do is according to downward direction. If you are at x comma y here, so then you are moving down, then you have to do what? X plus 1 comma y, because if you move down, your x value increases. So you have to update this as what? You have to update 1 comma 0 here. So at the index 1, that is the index 1, like you can see that the index 0 is indicating the right side movement. Okay, then index 1 is indicating what? Index 1 is indicating the downwards movement. Okay, and the elements at the index 1, they indicate the small change that you need to do in your like row and the column here. Now after this respectively, now after this, like once you have iterated on the right side and downward side, you have to move in the leftward also. Once your downward is also over, you have to move in the leftward. Now if you are at a particular cell, let's say x comma y, what will be the left direction? It will be x and y minus 1, because if you're in the same if you're moving leftward, so the x remains the same, y decreases by 1. So here your x value will be what? It will be 0, and the y value will be what? It will be minus 1 here. Now you can see this will be direction 2, and this is when you're moving on the left side here. Now after this, like once your left is also done, you have to move upwards. So in order to move up, what will happen? If you are at x comma y and you're moving upwards, so that will be nothing but x minus 1 comma y. So you are decreasing your x, and y is the same, so minus 1 will be done here, and 0 will be updated here as well, because in the y there is no change when you are moving upwards. So at the index 3, you have got the movement when you are moving in the upward direction. Okay, this is what we have. Now we have prepared our dx dy array. So whenever, suppose that if I have to move like if I have to move in the right direction, so my index will be initially equal to 0, and whatever current row that I am at, it will be updated to dr of index here. Okay, and column will be what? Column plus dc of the index. So initially, if the index is at 0, if the index is initially at 0, so at the 0th index I have got this much change. So this value will be 0 and this value will be 1. So basically it will help me, it will allow me to move from one cell to another in the rightward direction. And if I want to move downwards, then my value will increase one by one. Now what will happen because of this? Initially what will happen here is my index value will be what? Initially, if you will see, we'll declare a resultant variable here, like which resultant here, which will be storing the final answer one by one. And initially we'll start the row and the column from 0 comma 0 here, and we'll put this particular element inside. So we'll put 1 here. Now after this, we have to move in the, like, we have to try and move first of all in the rightward direction. So if my index value is 0, it indicates the rightward direction. If it is 1, it will indicate the downward direction. If it is 2, it will indicate the left direction. If it is 3, it will indicate the upward direction movement. Okay, right now my index is 0. So what I'll do is, as I said, row plus dr of idx. Okay, and my column will be what? Column plus dc of idx. Then what will happen is my R will remain the same, and my column will increase by 1. So I'll be able to move to the next cell, that is 2. The moment I move to 2, this particular cell, it is a valid cell. So this value will be entered here, and then we'll again try to move on the right side. So we'll access the access the dr and the dc array at the 0th index. Now the next element that we see is basically what? It is 3. So like we'll be at this element, we'll put this inside. Then after that, the index is still 0. We move here. Now you see that at this point, what do we have? We have got the cell value, the value at this cell is 4. So we'll put this in the answer. Now if you see, if I try to identify another cell on the right side, so that is outside the boundary here. So this means that my rightward down movement is done, and I should increase my index. Now my index will become 1. Now whatever is at index 1, like we have to see this. So whatever is at index 1, that indicates what? The elements at the index 1 in the dr and the dc array, they are indicating the change that you should do in order to move down. So when you're moving down, what will happen? Your row will increase by 1 and your column will remain the same. So basically now index will be 1, so the updates will be done according to the downward movement here. So r plus 1 will be done and column will be the same. So then you will move down. It is a valid cell, you will put this in the answer. So you will put 8 also. Then you will move down again because index will be still 1. It is valid, so you will put this 12 also. You'll move down again. 16 is also valid, so you will put this. Now if you try to move down, it is outside the range. When you get outside the range, increase your I, because now you want to move in the left direction. So increase your I, it will be 2. Now the thing is that you want to make the changes in the row and the column such that you can move in the leftward direction. So now this will be the index. Index will be 2, and when you're moving leftwards, then the row will remain the same. It will be 0 only. There will be 0 change in the row, but the column will decrease by 1, and that is what you can see at the index 2 in the dr and the dc array. So what will happen when you move leftward? 15 will be there. So 15 will be updated. Then again you can move leftward if you will check. So the row and the column will be here at 14. Then you will put this also. Then you will move again in the leftward direction. You will be at 13. You will put this as well. Now when you try to move left, you are going outside the boundary. So in such a case, you will say that, okay, we need to increase the index. Now the index value will be 3 here. When it is 3, it means that you are planning to move in the upward direction. So let us say that when you are moving in the upward direction, what will happen? The row will decrease by 1 and the column will remain the same. That is what you can see. So for the current row column, now you will decrease the row and the column will remain the same. So you'll be at 9. You will print 9 as well. You'll again go up and you will print 5 as well. Okay, fine. Now once this is done, what will happen next? Now if you see, can you move more upwards? Actually you should not, because you are inside, like you have already used 1. So now you want to move in the rightward direction. So when you'll increase the index value, it will become 4. Now when the index becomes 4, it is outside the range, because I have indexing 0 1 2 3 only. So when it becomes equal to 4, I can take a modulo with 4 here. So when I'll take the modulo with 4, it will become 0. So this means that I'm indicating that I want to move in the rightward direction again. So in order to keep the index between 0 to 3, always I need to do what? I need to update the index as index plus 1 modulo with what? Modulo with 4 here, so that it is always between 0 to 3. Whenever it exceeds, whenever it becomes 4, it will again start from 0. So from 5, what will happen? Now you'll be at 6. You'll put 6 also inside the answer. Then you'll put 7 also inside the answer. Very good. Now after that, when you see you cannot move rightwards, you'll move downwards. So now 11 will be put. So the index value will be increased. And since you'll be moving in the downward direction here, so 11 will be there in the answer. Now you cannot move downwards, you will move in the left side. So index will be increased. Now it will be equal to 2. So you'll move in the left side, you'll move to 11, you'll put you'll move to 10, you'll put 10 also inside the answer, and then your iteration is basically over. So you will stop here. So you can see that how by using the index variable here, it is helping us to determine the direction. And in order to keep the index under control, we are always taking the modulus with 4, so that the index always remains between 0 1 2 and 3. Now dr and the dx array are representing the small change that I need to do in the row and the column respectively, based on the direction in which I want to go. And you can see that at the end we are able to store the final answer. Let's have a look at this code here. If you will see, first of all, we will take the size of the row and the column. Now why do we do mat of 0 dot size for the column part? Because if you will see here, let's say if this is the grid that I had here, now in this case, how many rows are there, how many columns? So the number of rows are basically equal to nothing but 3 here. So if you see, let's say this is matrix, so this will be mat of 0 here, okay, this will be mat of 1 here, okay, and this will be mat of 2 here. Now when I'll take out the length of the mat, it will give me the length 3, because there are 3 rows here. Now how do I get the size of the column here? How do I get the column? So if you see, mat of 0 itself is behaving as an array, as a 1D array. So if I take out the size of the mat of 0, then I'll be able to identify that how many elements are there in the column. So that is why for the column length, we need to do mat of 0 length. Now after this, once we have got this, then initially we'll mark all the cells as not visited, because as I said, if we have already visited a particular cell, if we have already used a particular cell, we were not going to it again, correct? So that is why whenever we were trying to move to a cell which was already visited, then we changed our direction. We used to increase the index here. Now what will happen here is, we have updated the dr and the dx array accordingly, as I had told you. Firstly the right direction, then the down, then the left, and then the upward direction. So the updates are done in the dr and the dc array like that only. After that, my row and column will be initially at 0 comma 0. My index will be 0, because initially I want to move in the rightward direction. Now I'll iterate for how many times? I'll iterate for m cross n times. Basically I want to iterate throughout the matrix. So the number of elements will be n into m that I want to iterate for. So I'll iterate for this many times. Whatever element I am currently at, I'll store it in my result, and then after this I'll mark it as visited, because I don't want to come to this again. Okay, then the new row and the new column will be r plus dr of index and c plus dc of index here. Once I've got the new row and the new column, I'll check if it is lying inside the range, then I'll update my current r and the current c as the new row new column. But if it is not, like if the new row and the new column that I get, if it is inside the range, then I'll move to those cells. Otherwise what I'll do is, I need to change my direction, so I need to update the indexing here. So the index will become index plus 1 modulo with 4, so that it is under control. After that, like after we change the direction, then we will update the row and the column accordingly, and at the end, when the resultant list is ready, then we'll return it. Now if you see, the time complexity of my code is going to be what? It is going to be basically order of n cross m here, because we are going to iterate throughout all the elements of the matrix. The space complexity is what? It will be order of n cross m, because I'm using a resultant list here, which will be storing all the elements of the given matrix in the question. Now let's try and see if there is any other approach that we can apply. Now this was a very good approach, but we can apply another approach, that is the concept of using 4 pointers for solving this problem. Let's have a look at that. So let's say this is the matrix that you have. Now understand one thing, that you have a topmost row that you want to access. Okay, then you also want to access something from the bottom, because understand one thing, you want to access the topmost row, then you wanted to access the rightmost column, so that's why you need a right as well, you need a right pointer. Then after that, you want to access the bottommost row, then you want to access the leftmost column, so you need a left variable for that. So these are the 4 pointers that you need, because as I told you initially, you want to access the topmost available row at that point, then the rightmost available column, then the bottommost available row, and the leftmost available column. So these are the 4 things that you want to access. So that's why initially what will happen is, top will be at 0, left will be at 0, and the right will be at the last column, and the bottom will be at the last row. Now after that, like as of now, I want to I'll iterate until which point. Now you can understand one thing, that till the time the top is less than equal to the bottom, because the topmost row should not cross the bottom row. This is a basic fundamental rule of 2 pointers that we need to apply, that the pointers should not cross each other, and the left column should be less than equal to the right column. This is something that we need to check here. Now initially when I'll start off, so what will happen here? If you will see, initially when we start off, so we are basically in the topmost row. Now we want to print the elements of the topmost row. So can I say one thing, that we want to print all the elements of the topmost row from the left index till the right index. So every time my column is changing from left to right, and the topmost row remains the same. So I want to print all these elements here. I want to store all these elements. So what will I do for that? Basically, you can say that I want to run a loop. I want to run a loop from where? It's like I want to run a loop. Let's say I starts from the leftmost available column till I is less than equal to the right here. Then we will do I plus plus here. Okay, and then you can say that in the result we want to add what? We want to add the mat of like top, because topmost column will be there. Sorry, topmost row will be there, and the ith columns one by one I want to iterate all of them, and I want to process them. So basically it's like I will be here, then I will be here, I will be here, I will be here. So I want to iterate, I want to change the column in the topmost row, so that is why I'm indicating this with the variable I, and the topmost row will remain the same. So all these elements will get printed here initially, correct. So 1, 2, 3, 4, 5 will get printed here. Now once this is done, suppose that we have printed 1, 2, 3, 4, 5, we have stored this in the result, suppose. Then after this, can I say that my topmost available row is now one step below? So I need to decrease my top, sorry, increase my top. So what will happen now? Top will be plus plus and top will move here. So what will happen after this? After printing the topmost row, increase the top here. Now after that, what happens? After that, you have to print the rightmost column here. So you have to print the rightmost column. You want to print the rightmost column from where to where? From the top till the bottom, guys. Okay. So that is why what you will do is you will say that you want to print the elements of the rightmost column from the top till the bottom. So the row is changing here. Let's say row is indicated by I. So row is changing from top to bottom, and we are printing the elements of the rightmost column as of now. So you want to print this. How will we do this? So we want to print these elements. So you can see that the rightmost column will remain the same. So what we will do here is, let's say we will start the I here, and we'll start from the topmost row till I is less than equal to the bottommost available column till that point, and we'll do I plus plus. And in the result, what we can say is that we want to add the mat of I and then right, because we want to add all the elements of the rightmost column from the top till the bottom. So basically we want to add all the elements of the rightmost column from the topmost row available till the bottommost row. And after this is done, then my rightmost available column will decrease, so right should move one step inside. So I have to do a right minus minus as well. Now notice one more thing here, that after doing right minus minus, now we want to print what? Like there is something more that I want to tell, but I'll tell it after I have done a couple of more iterations. Now after this, what will happen is we want to print the bottommost column as of now, and we want to print the bottommost column from where to where? We want to print the bottommost column from the right. Sorry, we want to print the bottommost row as of now. Now we want to print the bottommost row from right to left. From right to left. So we want to print it from rightmost column till the leftmost column. So we are decreasing in terms of column, and bottom row remains the same. So it's like you can say that as of now, like although there is one more condition that I'll check, but we will talk about this by the end of this dry run. If you will see here, what I want to do is I want to basically run a loop starting from the rightmost column till I is greater equal to left, and then I want to do I minus minus. Okay, and in my result, what I want to do is I want to add the element of mat of, basically my bottommost row will remain the same, and my column will keep on changing from the rightmost column till the leftmost column here. So basically the elements will keep on changing like this. So we will move from the, like we'll move in the elements of the bottommost row from right to left here. Okay, now once this is done, we need to increase the bottom. Sorry, we need to decrease the bottom, because the bottom will come bottommost available row will come one step ahead, because the as we keep on traversing in spiral format, the size of the matrix keeps on shrinking that is available to print. So after this is done, then you need to do what? Then you want to do a bottom minus minus here as well. Okay, very good. Now after this gets done, once you have printed the bottommost as well, then you want to print what? You want to print the leftmost column from the bottom to the top. Okay, you want to print the leftmost column from the bottom till the top. This is something that you want. So your leftmost column will remain the same, and the row will change from bottom till top. So what you want to write here is, you want to write something like this. You want to write that your I will start from the bottom, okay, till I is greater equal to your top. Then you want to do I minus minus, fair enough. After this, you want to add what? In the result, you want to add mat of your I, because your row keeps on changing here. Okay, and the column is the leftmost column. So I, and then this is the left thing that you will write here. Now after this is done, you need to increase your left column also, because once you have used your current left column, you need to step one step ahead. So now left will be standing here. Very good. You will say that everything is working fine. Then after this, what will happen in terms of code? Now you will say that after this is done, then the next topmost row will be printed. Elements of the next topmost row from left to right will get printed, obviously, yes. So elements of the next topmost row from left to right will get printed like this. 7, 8, 9 will get printed. So you will see here that when they get printed, then the top will move one step down and top will come here. And then after this, now the elements of the current rightmost column needs to get printed. So you'll print 14, 19 from the topmost row till the bottommost, from the topmost row till the bottommost row, you'll print the elements of the rightmost column. So then right will come one step inside as well. So right will come here, right will come here. Okay, now you want to print what? You want to print the elements of the bottommost row here. So you'll print the bottommost row elements from the right to left. So you'll print them like this. So basically all the for loops that we have written, they are getting repeated indirectly. Now you will print the bottommost row. Now bottommost row will come here, bottommost row will come here. So you can see that as of now top and bottom are same. Now after this you want to print what? You want to print the element of the leftmost column. Okay, so you'll print the element of the leftmost column from bottom to top. So only one element will get printed here, and the left will move ahead, and the left will come where? Left will come here as well. Now at this point you can see that left is less than equal to right, top is less than equal to bottom. Now what will happen after this? After this what will happen is we want to print the element of the topmost row. So we want to print 13 here. So what will happen in this case is we'll print this element 13 here, and my top will go one step down. So top goes one step down here. Okay, so we have printed which particular element? We have printed this particular element here, and the top goes one step down. Now after that we'll try to print the element of the rightmost column, but that cannot be done because we'll print the element of the rightmost column from top to bottom, but top and bottom have crossed, so 13 will not get printed here, and the right will move one step inside. So what will happen is now right will cross the left as well. By now you can see that the top has crossed the bottom, and the right has also crossed the left. Now after this you want you have tried for the top row, you have tried for the rightmost column as well. Okay, now after this you will try for the left, you will try for printing the leftmost column element. Do I want to print the leftmost column element? No, because if the what can happen is in case of odd scenario, suppose that initially the top was less than equal to the bottom when you check the condition, but after you increase the top can exceed the bottom. So in order to, before printing the bottommost row elements and the leftmost column elements, we have to explicitly check, because initially when you will apply a while loop, initially you will definitely have a while loop where you will do what, where you will check that okay, top is less than equal to the bottom, and the left is less than equal to the right. But after some time, when the top, at one time what will happen is, you can see in the last step top and the bottom were same, and left and right were same. But when I printed the topmost, it crossed, so it crossed the bottom. So before printing, once you update the top and once you update the right, so sometimes what can happen is after updating the top and the right, initially they will be under control. Initially top and bottom might be equal, and left and right might be equal as well. But what will happen is after you increase the top and you decrease the right also, then it might happen that the top might have crossed the bottom. So we have to always check before printing the bottommost row that the top should be less than equal to the bottom. Okay, because we cannot directly print the bottommost row, we have to check that the bottommost row should not have been crossed by the top. In that case we'll print the bottommost row. And similarly, earlier what might have happened is left might be less than equal to r, but once I print right, so right will get printed, then right will cross, so I cannot print this left row again. Okay, because I've already printed it using r. So we need to check this, that before printing the rightmost column, we have to check that the left should be less than equal to the right here. This is one thing that we need to check here. Now after this is done, then you can basically end your iteration whenever the while condition is false. Let's have a look at the code here. You will see that initially what we need to do is we need to first of all take the length of the matrix. Then after that we have a resultant string. Initially we have the top, bottom, left, right. All these pointers are set at the boundaries. Then after this will iterate until the top is less than equal to bottom and the left is less than equal to right. Then we'll basically do what? We'll print all the elements of the topmost row, and we'll increase the top, that I already told you. Then we'll print all the elements of the current topmost row from the left to right direction. Then we'll do what? We'll print all the elements of the current rightmost column from the top to down direction. Okay, and we'll decrease our right also. Then after this is done, we will do what? We'll check that if the top has not crossed the bottom, because after increasing the top, chances might be that the top might have crossed the bottom. If it has not crossed the bottom, then in that case you will print the bottommost available row here, elements of the bottommost available row from the rightmost column till the leftmost column here. Then after this, what you will do is you will also check that if the left has not crossed the right, because after decreasing the right, sometimes the right might cross the left. If it has not crossed the left, in that case the leftmost column is available for you to print. So you have to print the elements of the leftmost column from the bottommost available row till the topmost here. So you are iterating from bottom to top, and you are storing this in the result, and then you do left plus plus, because your leftmost available column will shift by one step on the right, and then at the end you return your result here. Now, what will be the time complexity of this particular code here? If you see, again, we are iterating throughout all the elements of the matrix overall. So the time complexity taken will be order of n cross m, because we are iterating throughout the elements. Space complexity will also be order of n cross m, because I'm declaring extra resultant list, which will be showing all the elements finally in the spiral traversal format. Now let's try and submit this top and bottom approach code as well. Let's see if it is getting accepted or not. So yeah, let us submit this code and check if it is getting accepted. So you can clearly see that my code was able to pass all the test cases. I hope you have understood both the approaches. Please comment understood in the chat if you have understood this, and thank you for watching this video.